Today I'm going to go over how to create your trimmer head. So this part is going to be the introduction to parametric modeling. We are going to add in our global variables. This is going to be L, T, and S. Notice that T is given to us as this fixed dimension. L is going to be our changing dimension. You will only have one L value. At the end, your entire part should be able to change its total length to all three values. When you turn in this one part file, the grader will go in and be changing your equations to all three of these different L values. So make sure that your trimmer head can get longer and shorter without any issues. Our last variable is going to be S. Now, we're going to have to create an equation to apply this variable. So pay attention to how your sketch is set up. We have the front view here letting us know that we have 9 teeth in this comb and there are 8 spaces between them. The tooth and the space is going to be what we use in our linear pattern today. All of these hidden lines and center lines you see, you do not need to add to your model. This is what is represented in your technical sketch or drawing when we start creating them. So they are not lines you need to add in this sketch. Also note that you need to use your entire height of 2.5 to define this right profile sketch. This part is going to be built in inches, and we're going to start on the right plane for our right profile. So with SOLIDWORKS open, we're going to select that right plane and bring it normal to us. And then I'm just going to create that rough sketch of that right profile. So I'm going to start with my line segment. I'm going to make sure that I am connected to the origin. And I'm going to use these guide relationships, that horizontal is showing up now, as I create this sketch just to save myself time. If you use these guidelines, you won't have to put in as many relationships. Now that you have that basic sketch all outlined, so we had a horizontal line, make sure that horizontal relationship is there. Then we have a vertical line, so you should have a vertical relationship. This slant will have no relationship. This top vertical line needs that vertical relationship. If you have this coincident that popped up on your top, go ahead and click it and delete it. That is trying to throw in a relationship to line up that midpoint with our origin, and we do not want that. For your top line, you should have a horizontal relationship, and then this last vertical line should have a vertical relationship. Once we have all of our relationships in place, including that coincident because we're attached to our origin, we can then start our dimensions. Remember, the first dimension you place is going to scale this sketch. So I'm going to select my Smart Dimension icon, and I'm going to start with the height because that is my largest dimension. So I'm going to select that top edge and my bottom edge, bring that dimension over, and this is shown in the front view as 2.5. Do a double check that your part window is in IPS. We are in inches. So my 2.5 is accurate. Next, I'm going to still be in my Smart Dimension icon. I'm going to work my way around counterclockwise to make sure I don't leave off any dimensions. So I'm going to start with my horizontal bottom edge first. This dimension is 0.12. And then I'm going to start with the end point of my horizontal edge and the top line segment to give that distance, which is 0.85. Zooming in, so I just have a little better view of where I'm dimensioning, I'm going to now dimension from the top of my slanted line to the top of my part sketch, and this is going to be 0.62. Now I'm going to dimension the thickness of this top sketch, and it's 0.25. And then I'm going to create that last top dimension, which is from your vertical straight edge to the bottom end point of that slanted line. Bring that up, and that's going to be 0.62. As you can see, as we add in these dimensions, our part is slowly becoming more and more black, meaning we are closer to having our sketch fully defined. With this angle being blue, I know I can drag this endpoint around, so I need to dimension its height from my origin. So I'm going to select the endpoint, select my horizontal line, zoom in so you're not selecting the midpoint of it, and this dimension is 1.6. And I'm going to hit OK. As you can see, that right profile now is fully defined. If I did not include that total height from the front view, our sketch would still be underdefined. Remember, you have to have a fully defined sketch before you add in your features. So now I'm going, before I add in my extrude, because I need my global variables, we're going to create them. So I want you to go up to your toolbar, go over to Tools, and then all the way down to Equations, where that summation equation sign is listed. That's going to pop up your global variables and equations window. Under global variables, I want you to click down, and your first is going to be L. Type in L, tab over. SOLIDWORKS automatically adds the quotations around that value so it can be utilized later. And we're going to start with our L value at the smallest trimmer head size of 2.96. So I'm going to type in 2.96 and hit enter. As I hit enter, it evaluates to its true value, and another global variable opening pops available. Go ahead and click down. I'm going to put T in, tab over. This is your fixed variable, so it's 0.12, and hit enter. And for our last variable, this is going to be S. Now, this is going to be your first equation. Writing your equations in SOLIDWORKS does not need to include all of the parentheses we've always been taught in math. So I'm going to start with a parenthesis. Go to your global variables, and I'm going to select L minus my next global variable of T, asterisk for multiply, (9), parenthesis, that is my entire numerator, divided by 8. So I'm just taking the overall length given to me for this trimmer head is equal to my 9 teeth plus the 8 spaces. And I'm solving for S. So as we change our main length, the spaces between those teeth are going to get more narrow or wide. And then I'm going to hit OK. And that's going to evaluate to 0.235. Once you have all your equations or your variables entered, go ahead and hit OK. You will now see that an equation folder has popped up on your feature tree manager. If I hit that fly out arrow, you can see what global variables you have all created. So now I want you to go into your sketch, so click that sketch, go to Edit Sketch, and we're going to apply our depth feature. Go over to your Features tab and select that extruded boss/base feature icon. We're going to have our direction be blind, and now for your depth, this is where we're going to actually apply those global variables. Recall that to use your global variables, you must use your equal sign first. So we're going to hit equals, scroll down with our mouse, go and select your global variable of L, and then hit OK. You can now see that that part has been extruded to our initial L of 2.96 depth. Now we're going to start by creating our seed feature. Remember, before we use a linear pattern, that seed sketch has to be a fully defined feature, and then we can pattern it. Because our part has this slanted edge, if we sketch on the front face, we will be left with a small lip of material. So we are going to rotate our part to the back face and sketch on that flat back face. So go ahead and select your back face, bring it normal to you, go to your sketch tab and select that rectangular sketch. Make sure your first endpoint is connected to that bottom edge, and go ahead and bring your rectangle up. I'm going to select that Smart Dimension icon, and I'm going to dimension the height first. This is 1.25. Hit enter. I am now going to dimension the width of this space, which is my S variable. So I'm going to hit equals so I can use my global variable, go down and select that S value and hit OK. Make sure when you apply your global variables to your sketch dimensions, you see that summation pull up. If the summation sign is not before your dimension, it has not been applied, so make sure you hit that equal sign. So my sketch is still underdefined. I need to give it placement. So I already have the coincident relationship with the bottom edge, so now I need to give the dimension for the teeth. So I'm going to select the outside edge, and then the outside edge of that sketch. And that thickness, we're going to hit equals, scroll to your global variables, and select T, and hit OK. That summation sign pops up in my dimension. My sketch is now fully defined. My height is a normal dimension, but then the width and the spacing, you have those summation signs in front of. Then I'm going to come up to my Features tab and go over to the Extruded Cut icon. I'm going to change the direction to Through All and hit OK. We now have our first tooth of this trimmer head or comb cut out. Now we can go ahead and create our linear pattern. So I'm going to come up under my Features toolbar and go over to Linear Pattern. Always start at the top of your Features Simulation Manager so you can work your way down on what is all needed. So for direction 1, well, I want this pattern to be going in the horizontal direction. So you can select any horizontal edge, but since we're working on the bottom of our part, it just makes sense to select the bottom horizontal edge. We're going to have spacing and instances selected. Now for that distance, we need to apply an equation. So we're going to use our equal sign so we can utilize those global variables. And this is going to be T plus your S global variable, because we are patterning that tooth and the space over and over. So equals T plus S. Now for our spaces, we know that we have 8 of them. We are not going in direction 2, so you can hit that arrow. For your features and faces, if it did not automatically come up as that cut extrude, and it is empty, like this, you will hit your fly out arrow up top, come down your feature tree manager and select that cut extrude, and then hit OK. So we now have the teeth of this trimmer head all cut out. Let's go ahead and add in our filleted edges. So I'm going to go to my Features tab, go to that fillet icon. I'm going to select the top two edges of our trimmer head. Looking at my drawing, I can see that they have a radius of 0.25, and then hit OK. Now I want to sketch in my two top holes, so I'm going to select the front face of this top area and bring it normal to me. Go to my Sketch tab, select that circle sketch. Since they are the same size, I'm going to select both edges, hold my Control key down, and add in, not concentric, the tangent relationship. Not tangent either. I'm going to add in the equals relationship. I'm going to go in and I'm going to add in that equals relationship and then hit OK. Now I'm going to smart dimension one of my circles, and this diameter is 0.25. Hit OK. And then I'm going to add in those concentric relationships to these filleted edges. So select that fillet edge, hold your Control key down, select the outside edge of your sketched circle, and add in that concentric relationship. That is giving that sketch placement. I'm going to do the same thing to this other side. So select that arc, hold my Control key down, select my circle sketch, and add in that concentric relationship and hit OK. With those circles being fully defined, I'm going to go to my Features tab and up to that extruded cut icon. I'm going to leave direction 1 as being through all and hit OK. You can now see both of those holes are done. So if you look close, you're going to see a note at the bottom of that right face or right profile sketch on your assignment, and it says fillet all edges 0.03. Now it would take an extremely long time to manually clip every single edge in this part. So to save yourself time for your fillets, go ahead and hit your Control key and A. Control A will select everything. This works in SOLIDWORKS by selecting all the edges of your part. It also works when you are dealing with any files in a document or folder. You can select all instead of manually control and clicking on all of the ones you want. With all of our edges selected, under that Features toolbar, go ahead and go up to your fillet icon. You can see as that window pops up that every edge is selected. We're going to scroll down, and for the radius here, it's going to be 0.03. And then hit that green check marker, OK. You can now see those nice filleted edges. This would allow the comb of this trimmer to move smoothly through hair. Next, we're going to add our material. So coming over to your Feature Tree Manager, you can see this area saying Material Not Specified. Go ahead and right-click on that. Go up to Edit Material. This part is plastic, so we are going to go down our SOLIDWORKS material list all the way to where it says plastic. Hit that fly out arrow. We're going to just use the top one, ABS. ABS plastic. Hit apply, and then close that window. You can now verify on your Feature Tree Manager that ABS plastic has been added. That material is specified. Last thing we want to do is turn this part yellow. So anywhere on your part, right click, you're going to see this appearance color will pop up. Hit that drop down arrow next to it. With your appearances, you can choose just the face that's selected to change the color, just the boss extrude that's selected, a body of your part, or the entire part itself. So go ahead and select that part 1. Your color wheel options are going to pop up on the left over here. We're going to scroll down and select yellow, seeing our whole part turn yellow, and hit OK. Once it is done, we can now go and test our equations. So go up to that equations folder on your feature tree manager, right click and go to manage equations. We're just going to change our L value to 3.96 and hit enter. You can see that our trimmer head has now expanded without any issues. Go ahead and try your L value for 4.96 and hit enter. If your trimmer head can do all three sizes with no issues, then save your part and turn it in for your lecture work assignment. This is the awesome thing with parametric modeling. We can create 3 parts in a matter of a second just by changing one value. So applying those global variables may take a little bit of time at first, but it is a huge time saver later. Let me know if you have any questions.